Welcome to The Explainer. Let's just jump right in, because today we're going on a seriously fascinating industrial journey. We're going to uncover exactly how raw Earth transforms into the invisible, silent magnetic forces that are, quite literally, powering our entire modern world. It's a process defined by absolute extremes. We're talking intense heat, massive pressure, and atomic-level precision, all hiding in plain sight in the devices you use every single day. Now, you might think heavy industry is all, dirty and gritty, but forging a supermagnet, it actually starts in high-tech cleanrooms, where a single speck of dust could completely ruin the entire batch. Here, technicians very carefully weigh out three specific elements: neodymium, iron, and boron. And there's a very good reason for all this extreme cleanliness. Neodymium oxidizes almost instantly the second it's exposed to open air, so that means even a microscopic trace of oxygen contamination can completely destroy a batch of materials worth thousands of dollars.
Okay, so once we have our perfectly clean, pristine mixture of elements, things get hot, like really hot. This highly sensitive raw mixture is loaded directly into an induction furnace. And inside this crucible, it's melted down at temperatures well over 1300 degrees Celsius. To put that sizzling high heat process into perspective for a second, that is actually hotter than flowing lava. So the heavy hum of that industrial furnace and the sizzle of the molten liquid, that really marks the beginning of a radical physical transformation.
What happens next is this incredible rapid-fire sequence. Once we have that glowing liquid alloy, it undergoes a process called melt spinning. The molten metal is poured, just splashing directly onto a cryogenic metal wheel that's spinning at crazy high speeds. The moment it makes contact with this freezing wheel, that glowing liquid alloy freezes instantly. I mean, in just a fraction of a second, it turns into these paper-thin metallic ribbons. But we aren't done breaking it down. Those paper-thin flakes then go into a high-energy ball mill. Under a strict nitrogen gas atmosphere, again, to prevent that oxidation we talked about earlier, these flakes are completely crushed and ground down until they become an ultra-fine powder. We are talking about microscopic grains here, finer than flour and actually thinner than a single human hair.
Which brings us to a pretty massive question. After all this intense melting at 1300 degrees, the rapid cryogenic freezing, and the relentless crushing into microscopic grains, is it a magnet yet? Well, here's the surprising twist. No. Despite all of this high-tech processing, these microscopic metallic grains are completely devoid of any magnetic pull. At this stage, they are entirely inert. Basically, they're just magnets in waiting.
So the absolutely crucial part is how we actually take that inert powder and give it potential. And that happens through a critical process known as magnetic grain alignment. That flour-like, non-magnetic powder is packed into a specialized pressing mold, and as heavy hydraulic presses physically compress the powder, something invisible but incredibly powerful happens. A powerful electromagnetic field pulses straight through the mold. In that exact fraction of a second, millions of chaotic, microscopic metallic grains suddenly snap into perfect formation. It's literally like millions of tiny soldiers instantly falling into line.
Right, so once those microscopic soldiers are in perfect alignment, we have to lock them into a solid form. The newly aligned block goes through a process called sintering, where it gets heated up once again, this time near 1000 degrees Celsius. This intense heat fuses those aligned grains into a rock-hard, solid block. From there, it's finally ready to be shaped. But because it's so incredibly hard, it requires high-precision diamond saws and high-tech lasers just to cut it down into its final precise shape.
But again, we hit this moment of incredible tension. Because even after the alignment, the sintering, and all this high-heat laser cutting, the solid block still has zero pull. If you held it in your hand right now, it would just feel like a heavy, normal piece of metal, totally inactive. It only becomes a true magnet in one dramatic, defining moment of ignition.
And that moment of ignition relies on sheer, overwhelming power. To bring the magnet to life, this block is placed inside a heavy copper magnetizing coil. Then, a massive surge of electric current is fired completely through it. This dramatic electrical spark generates a localized magnetic field that is literally tens of thousands of times stronger than the magnetic field of the Earth itself. In a single microsecond, that massive electrical surge forces every single magnetic domain inside the block to lock firmly into place. The magnet is suddenly alive, and it now holds enough internal strength to maintain its raw magnetic power for centuries.
Listen, a field that is tens of thousands of times stronger than the Earth's is absolutely nothing to take lightly. We need to shift gears here for a second and talk about the visceral danger of these supermagnets, because the raw power we just locked into these blocks creates genuine lethal forces and major factory hazards. If they're handled carelessly, just 2 coin-sized neodymium magnets can snap together from a distance with a violent shockwave. They will literally snap together with enough crushing force to severely injure a human hand.
Because these forces are so unforgiving, rigorous safety rules are an absolute necessity. Factory workers on the floor are required to wear heavy, reinforced gloves at all times. On top of that, personal items, rings, metal watches, they are strictly banned on the factory floor to prevent them from being violently ripped toward a magnetizing block. And this danger extends way beyond the factory. Magnetic fields this strong demand respect everywhere they're used. You see this startling reality in hospital MRI suites, which rely heavily on these intense magnetic fields. If a stray metal object, say a pair of steel scissors, is brought too close to an active MRI scanner, it can actually be pulled right out of a doctor's hand and become a high-speed, deadly projectile flying across the room. This is exactly why hospitals enforce such strict, non-negotiable no-metal protocols near their scanners.
Now, obviously not every single application in the world needs the terrifying raw power of neodymium. There is a huge difference between our high-tech supermagnet and its everyday cousin, ferrite. While neodymium is the undisputed king of raw power, it's also an expensive industrial bottleneck. Meanwhile, ferrite, or ceramic magnets, are made from low-cost iron oxide and are quite literally fired in kilns like pottery. Now, while ferrite magnets are significantly weaker than neodymium, they have their own superpowers, right? They're incredibly cheap, they're completely rust-proof, and they are highly heat-resistant. This makes ferrite the perfect, reliable choice for everyday household items. You'll find these darker, rough gray magnets stuck to your fridge, powering your microwave, or sitting inside the speakers of a classic car.
But when it comes to the advanced technology of the future, neodymium remains king. And that brings us to a massive macro geopolitical reality. Global industries like electric vehicles, wind turbines, robotics, and advanced aerospace systems, they simply do not function with the raw power of rare earth supermagnets. Yet there is a severe bottleneck here. Currently, the overwhelming majority of global rare earth magnet refining and processing is controlled by China. Because these supermagnets are so deeply critical to modern infrastructure, governments worldwide are now recognizing this bottleneck and investing heavily in their own processing capacities. And they're doing this simply to ensure that the global supply chain doesn't break down and that the highly advanced infrastructure we all rely on doesn't grind to a total halt.
So, as we pull back from the intense heat of the induction furnaces and those complex global supply chains, we arrive at the reality of the devices right in front of us. These incredibly powerful magnets are quietly powering the modern world. They are the unseen forces driving the giant spinning blades of wind turbines catching the breeze at sunset. They're spinning the highly efficient motors inside electric vehicles, and they are providing that satisfying snap of the tiny earbuds case closing right there in your pocket.
The next time you glance at your fridge or pop in your earbuds, I want you to remember the intense journey hiding in plain sight behind them. Remember the 1300-degree furnaces, the extreme hydraulic pressure, the invisible electromagnetic fields, and the atomic-level precision that literally makes our modern conveniences possible. So, before we wrap up this explainer, I have a question for you, and I want to hear your answers. What is the one magnet on your fridge you would never ever take down, and where is it from? Tell me all about it in the comments below. And hey, if you love uncovering the hidden science behind the everyday things around us, make sure to like, subscribe, and turn on notifications so you never miss our next deep dive. See you next time.